Kirkwood Math. All right, ladies and gentlemen, here we are. We're going to start learning about greatest common factors and how to solve that. So we're going to be able to use factors, multiples, and prime factorization to find greatest common factor of two given numbers. And you should be able to explain why a pair of numbers have a certain GCF. So first, I want you to look at my note to learner here. Basically, there are a few different ways to find the GCF and the LCM, but if you truly understand what they mean, then any method will work for you. And what that's basically saying is that, and it works in most math, there's lots of different ways to solve problems in math. And as long as you understand what you are doing, you can use any way to solve this, okay? Because sometimes certain situations call for certain types of ways to solve the problem. But don't get caught up on the way to solve the problem. Like it says, if you know what you're doing, you can use any way, okay? So the first way that we're going to talk about is the T-chart method for GCF. Now, T-charts, I think, are really easy for small numbers. And probably most of the numbers we're going to work with, but the reason we do a T-chart instead of just listing the pairs out is because the T-chart has you list factor pairs, and a lot of the times students will forget the pair to the factor. So they'll start listing and they'll go, oh, 3 goes into 36, but then they'll forget to put in the factor pair that goes with 3, which would be 12, okay? So this way we list our factor pairs in numerical order. Then we identify all of those common factors, and then we find the one that is the greatest one they have in common. Okay, so we're going to do that with 36. So watch how I do this, all right? I'm going to go start from the bottom and say, okay, 1 times 36 is 36. So really this line in my T-chart is showing me what numbers multiply together. Okay, now I'm going to go numerically. What's after 1? 2. Can 2 go into 36? Yes. It can go in 18 times. Can 3 go into 36? Yes. 3 times 12 is 36. Can 4 go into 36? Yes. 9 times. 4 times 9 is 36. Can 5 go into 36? Oh, no. 36 is not divisible by 5. 6. Can 6 go into 36? Yes, 6 times 6 is 36. And as soon as you get this like a double or basically a repeat of a number, you know you're done with your factors, okay? As soon as you get a repeat of a number or a double, you know you're done looking for factors. You've found them all. All right, so we're going to do the same thing over here with 48. So we have 1 times 48 is 48. 2 times 24 is 48. 3. So my trick for 3s is if I add the 8 and the 4, if I add the digits together and the answer is a multiple of 3, then I know it's divisible by 3. So 8, 9, 10, 11, 12. 12 is a multiple of 3, so it does go in. Let's see, it goes in 1 and I think 16 times. Okay. 4 can go into 48. That goes in 12 times. 5, no, 5 is not a multiple, or a factor, sorry. 5 is not a factor of 48. 6 is, and that would be 8. 7, no. 8. Oh, I just repeated a number, right? So when I'm going in order, if I come back to a number I already have, so I'm repeating a number, or if you get those doubles, then you know you're done. I'm going to stop right there. So now I'm going to just circle or identify all the ones that they have in common. So they both have a 1. They both have a 2. They both have a 3. They both have a 4. They both have a 6. They both have a 12. And I think that's it. Okay, so now I'm going to highlight, or truly identify the one that they have, the biggest one they have in common, which in this case is 12. 12 is the largest number that 36 and 48 have in common. So therefore, my GCF is 12. So that is finding GCF using a T-chart method. Okay. Now we're going to go back to that prime factorization that we did earlier, and I'm going to show you how to use that to find your GCF. So in this case, these work for really large numbers, okay, because we don't always know all the factors of a really, really big number. And so sometimes it's easier to just do the prime factorization and identify it than to actually go through and try to remember all the factors, okay? So these work really well for large numbers. Okay, so we're going to basically list all those factor pairs in that tree method until we get all the prime factors. And then we're going to use a little Venn diagram to find the common prime factors. And then we're going to end up multiplying those common prime factors to get our GCF, okay? So again, we're going to do our factor tree. So I'm going to think of two numbers that multiply together to make 36. We just thought of a bunch of those numbers, but why don't we do 3 and 12? Okay, circle your prime number, break apart your composite. 12 is 3 times 4. So these are prime, break apart your composite. 2 times 2. All right, so the prime factor for 36 is 2 times 2 times 3 times 3. Awesome. Now down here, we're going to do 48. So why don't we do 4 and 12 again? 4 is not prime, so we're going to break that apart. We've got 2 2s. 12 is not prime, so we're going to break that apart into 3 and 4. And again, another 4. So for 48, our factors are 2 times 2 times 2 times 2 times 3. Okay, so now we're going to list them, okay? So we're going to put all of our 48 factors on this side and our 36 factors here, and then anything that they have in common we're going to put in the middle. Okay, so I know that they have 2 2s in common, another set of 2s in common, and a set of 3s. So in the middle I'm going to do 2, 2, and 3. And let me see if I can just do a different color really quick. Yeah, 2, 2, and 3. Okay, so you can see here. So notice that I'm only taking one of these numbers because I'm asking myself, what numbers do they have in common? They have a 2 in common. They have another 2 in common. Okay, and then the stuff I'm putting on the left here is going to be any leftover number that they're not in common with. Okay. So now, I don't remember what color this was. This one. We're going to do 48. So again, we're going to take the two numbers that are left over, and those are going to go in this side of my thing. So our GCF is found by multiplying the ones they have in common, the middle numbers. Okay. So I'm going to go ahead and do the middle numbers, which is 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. That is our GCF of 36 and 48. And the nice thing is because we use the same numbers, if I go back, I know that I got the same answer, so I know I did it correctly. Okay, so prime factorization method is really helpful for really, really big numbers. Okay, the T-chart method is really helpful for just kind of everyday numbers or kind of smaller numbers. All right, so now we're just going to practice, okay? So go ahead and find the GCF of these two sets of numbers on your own. Use whatever way you want. You can use a factor tree with prime factorization or a T-chart, and then come back and join us and see if you're right. Okay, so both of these numbers are pretty small. I normally would have just done T-charts for both, but I wanted to show you the prime factorization and prime factor trees again, just to, in case you want to use that way. So on this side for 6 and 15, I made two T-charts and found 3 is the largest number they have in common for factors. And then on this side for 12 and 18, I made 2 prime factor trees. I found their prime factors they have in common. Those are circled in red. They went in the middle of my Venn diagram with the leftover pieces on each side. And then you just multiply what's in the middle to get your GCF of 6. And again, I could have easily done this with a T-chart as well. I also could have done this side with prime factor trees. It's up to you. Okay, so what we have now are some word problems that go with using GCF. So we have a 6th grade classes competing in the school field day. There are 32 girls and 40 boys who want to participate. Each team must have the same number of girls and the same number of boys. What is the greatest number of teams that can be formed? How many boys and how many girls will be on each team? Okay, so we're going to highlight some of the things that are important here. We've got 32 girls and 40 boys, and the teams have to have the same number of girls and boys. Okay, and we want to know the largest team and how many on each. So in order to solve this, because we're trying to make equal groups, we need to find the GCF of 32 and 40. We need to know what's the largest kind of groupings that we can make with 32 and 40. So again, these numbers are kind of small. I'm going to use a T-chart. I think it'll also help us with this last part of explaining how many boys and how many girls will be on each team. Because first we just have to figure out how many teams. Okay, so let's list the factors. So 1 times 32, 2 times 16, 3 does not go in, 4 times 8, and 5 does not go in, 6 does not go in, 7, nope, and then 8. Okay, so those are my factors for 32. And then for 40, 1 times 40, 2 times 20, 3, no, 4 times 10, 5 times 8, 6, no, 7, no, 8. Oh, I'm back at 8. Okay, so that's what we have right here, and I'm looking for the largest one that they have in common. So we've got 1s and 2s and 4s, and then don't forget about these 8s. So 8 is going to be my GCF. So we are going to have 8 teams for this field day. Now I have to figure out, but how many boys and how many girls are there going to be on this team? Well, the number of boys, if you remember, 40 was boys here. So I'm going to look at my T-chart and look at the factor pair that goes with 8. That's going to tell me how many boys are on each team. So 5 boys on each team. And then if I go and I look for the number of girls, they were 32. So I'm going to go to my 32 T-chart. And again, I'm looking at the factor pair that goes with my GCF, which is 4. So that means I'm going to have 4 girls. So 8 teams made of 4 girls and 5 boys each. So 9 total people on each team. Okay? All right. There you go. So the next problem on here is actually very much the same, except we're dealing with apples and pears and arranging them in baskets. So again, try this one on your own, see what you get, pause it, and then come back and join me and see if you can get the same answer as me. All right, so if I go and I make my T-charts for these apples and pears, I'll find that 4 is the greatest common factor. So there are 4, oops, I put teams. We're not dealing with teams again. It's supposed to be baskets. Okay, 4 baskets. And inside each basket, we're going to have 3 apples because 12 was the number of apples. And I'm looking at the factor pair that goes with my GCF. And 4 pears. Okay, and that's it. That's how we find GCF, guys. So keep practicing, and I'll see you in the next one.